Hello, everyone. Welcome to today's lesson. This begins on page 28 in your textbook, and this is called reflections. We're going to look at, your textbook shows two types of reflection. I'm actually going to show you a third type as well. If you look carefully here, you will see a graph. The graph in black is supposed to be y equals 2 plus the square root of x. All right. Well, if you were to reflect that across the x-axis, in other words, the x-axis acts as a mirror, it would turn into this red function shown down below. All right. Now, how do we take an equation? How do we reflect it across the x-axis? Well, according to this blue box right here in your notes, it says to reflect a function f of x across the x-axis, the function becomes negative f of x. So in other words, you take your equation and you replace f of x with negative f of x, or another way to think of it is you replace the y, because that is your f of x, remember, replace the y with negative y. All right? So that's how you take a function and you reflect it across the x-axis. Now, of course, you wouldn't leave the negative in front of the y. You would then multiply both sides of your equation by -1 to end up with y again by itself, or f of x if you decide to use that. All right. So let's look at the next type of reflection that we can do as well. Now again, notice the black function. That's still y equals 2 plus the square root of x. And now you can see that it's been reflected across the y-axis to become the red function that you see, all right? Well, how do we take a function and reflect it across the y-axis? Well, if you, again, look at this box right here, it tells us that to reflect a function f of x across the y-axis, it becomes f of negative x. And the easiest way to think of that is you replace the x with negative x. Okay, you do that in your function, and then you simplify your function and see what you end up with. Now, there's a third type of reflection as well that I'm going to consider here, and I want you to consider it as well. You can also take a function and reflect it across the origin. The origin is right there, of course, the point 0, 0. And basically, it sort of acts like a 180-degree rotation around the origin. So your new function would end up looking something like this right here, all right? From the black one, that is. Now, to reflect a function through the origin, you actually do both of those things. So to reflect in the origin, you make both replacements. So you replace y with negative y, and you also replace the x with negative x. Okay? So you basically do both things. I'm going to consider all three of those reflections now as we look at some examples on the next page. So here's example number 14. This is on page 29. And now it says, find the new function after a reflection across, well, first of all, number 1, the x-axis. And remember what you do for that. You replace the y with negative y. Then, what would the new function become if you reflect it across the y-axis? And that's where you replace the x with negative x. I want you to consider a third case as well. And this is going to be the origin. All right? Now, there's a reason I want you to see how it works with the origin, because the next section talks about symmetry, and it deals specifically with symmetry through the origin. Okay, so let's see what we do. Let's do part 1 here. Let's do A. Now, if you were to take this function here, and if you wanted to reflect it in the x-axis, remember what you do. You take the y and you turn it into negative y, which is the same thing as taking f of x and turning it into negative f of x. So here's what the new function would look like. All right. Now again, you would not leave the negative in front of the f of x. You'd multiply both sides by -1. So the new function would become, if you multiply everything by -1, negative x plus 4. Or you could even call that 4 subtract x if you wanted to. All right? So there is the new function reflected through the x-axis. All right, part 2. What if you wanted to reflect it through the y-axis? Well, that means that your x turns into negative x. So in your function, you just draw a line there. In your function, now you can put negative x here if you like. So the x comes out, gets replaced with negative x. Nothing happens to the minus 4, by the way. So here is the function, the new function, that you would get. Oops, that should be a minus there, sorry. Here's the new function that you would get if you reflected the original function through the y-axis. And for number 3, what if you reflected it through the origin? Now remember, in that case, the x becomes negative x, and also the y becomes negative y. Oops, negative y. Sorry about that. So here's what you would end up with. Negative f of x, you could call that y if you wanted to, negative y, is equal to, and then I have x replaced with negative x. The minus 4 does not change. So in your next step, you would have negative f of x equals negative x minus 4. And now, of course, if you multiply both sides by negative 1, here is your new function. This would represent a reflection through the origin. There we go. Okay? And that's all this section is really asking you to do. Take some function, whatever function you're given, and determine what the new function would be if you reflected it either through the x-axis or through the y-axis or through the origin. All right? And they all work out pretty much the same thing. So I'm going to leave those other exercises there for you to try, B, C, and D. And also practice number 14 as well, on the bottom of page 29. They all work pretty much the same thing. All right, they're all pretty much the same thing. Remember to keep checking your answers in D2L. If you run into any problems with anything, please be sure to pop me off an email, and I will certainly get back to you. Okay, bye-bye for now.